Witness the fascinating process of crafting electric motors, from precise stator winding to rotor assembly powering industries, vehicles, and the future of motion. The Envoy Bronze Foundry has established itself as a forward-looking facility by integrating green furan technology into its casting operations. This modern resin system represents a significant improvement in the foundry industry, especially in terms of environmental performance and working conditions. Traditionally, furan binders have been widely used in sand casting due to their excellent strength and dimensional accuracy. However, one of the major drawbacks of conventional furan systems has always been the unpleasant odor and excessive smoke released during pouring. Envoy's adoption of green furan directly addresses these concerns, creating a cleaner, safer, and more sustainable workplace. When molten bronze is poured into molds prepared with green furan, the amount of visible vapor generated is noticeably reduced compared to traditional systems. This means the casting floor no longer fills with dense fumes that obscure visibility and create discomfort for workers. More importantly, the distinct chemical smell normally associated with furan resins is drastically minimized. Employees and visitors immediately notice this difference, as the working atmosphere feels less harsh and significantly more breathable. This improvement not only benefits worker health, but also demonstrates the company's commitment to cleaner industrial practices. Beyond the reduction of fumes and odors, green furan also maintains the essential technical qualities required for high-quality bronze casting. The system provides excellent bonding strength between the sand grains, resulting in molds that can withstand the high temperatures and pressures of molten metal without deformation. This ensures the castings achieve precise dimensions, fine surface finishes, and minimal defects. Envoy therefore gains both environmental and technical advantages without compromising on production quality or efficiency. Another important aspect of green furan technology is its contribution to sustainability. By lowering the emission of harmful compounds during casting, it helps the foundry comply with stricter environmental regulations while also reducing the need for expensive air extraction and filtration systems. This eco-friendly binder system aligns with global trends in responsible manufacturing, where industries are increasingly expected to adopt processes that minimize environmental impact. For Envoy, the decision to use green furan reflects not only technological innovation, but also a corporate philosophy of environmental responsibility. The practical benefits extend even further. A foundry using green furan experiences less residue buildup in its molding equipment, making maintenance easier and more cost-effective. In addition, the improved working atmosphere contributes to higher employee satisfaction and productivity. Workers feel more comfortable and motivated when they are not exposed to strong odors or thick smoke. Visitors, clients, and partners who tour the facility also recognize these improvements, strengthening Envoy's reputation as a modern, clean, and advanced foundry. In conclusion, Envoy's bronze casting workshop demonstrates how the integration of green furan technology can transform traditional foundry operations. By greatly reducing the fumes and unpleasant smells associated with furan binders, the system creates a healthier work environment and supports sustainable production practices. At the same time, It delivers the high-performance characteristics necessary for producing accurate, durable, and aesthetically pleasing bronze castings. Envoy's adoption of this innovative binder system highlights its commitment to innovation, environmental care, and the well-being of its workforce, setting a strong example for the wider foundry industry. In the Longbank Motor Factory, workers are seen transporting large stators used in the production of industrial electric motors. Each stator appears massive and requires careful handling. The workers skillfully perform their assigned tasks, ensuring that every step in the assembly process is precise. Every motor is closely monitored under their supervision to maintain high manufacturing standards and guarantee reliable performance. This teamwork and attention to detail reflect the company's commitment to quality in industrial motor production. NIDE Corporation is a global leader dedicated to providing customers with fully optimized and integrated solutions for motor manufacturing. Since its establishment, the company has been committed to continuous innovation and improvement, always striving to deliver excellence in both products and services. Guided by the principle of professional, prompt, sincere, and innovative, NIDE aims to help customers achieve higher efficiency, better quality, and added value from their investments. NIDE Corporation consists of 4 subsidiary companies: Ningbo NIDE Mechanical Equipment, Jiangsu NIDE Automation, Jiangsu Shannon Mechanical Equipment, and Ningbo Haishu KN International. Each company specializes in different aspects of motor manufacturing, automation, and international trade, forming a comprehensive industrial network that supports NIDE's mission of delivering world-class solutions for motor production. The company's business structure is divided into 3 main divisions: motor manufacturing machines, motor components, and technical consultation and turnkey project services. Through these divisions, NIDE provides customers with a complete set of high-quality machines, components, and professional services that cover every stage of motor production, from the manufacturing of stators and armatures to final testing and packaging. Over the years, NIDE has successfully expanded its global presence by supplying products and services to more than 40 countries across Asia, Europe, America, Oceania, and Africa. The company has established sales offices, ensuring localized support for its customers worldwide. Furthermore, NIDE operates 2 after-sales service centers in India and is in the process of establishing more service networks in Turkey, Brazil, and other key regions. This global infrastructure allows NIDE to respond promptly to customer needs and maintain close partnerships with clients around the world. One of NIDE's strongest advantages lies in its attention to detail and extensive manufacturing experience. The company offers fully automatic production lines and standalone machines for the manufacturing of stators and armatures for various types of motors, including induction motors, servo motors, DC motors, and series-excited motors. These production systems are designed to provide consistent, high-performance operation, ensuring reliability and precision at every stage of the process. To achieve such high standards, NIDE invests heavily in advanced technology and strong R&D capabilities. Its engineering team consists of experienced experts who continuously develop new solutions to meet the evolving demands of the motor industry. Equipped with first-class processing machinery and modern testing facilities, NIDE is capable of customizing special-purpose machines tailored to the unique requirements of different stator and armature designs. The company's commitment to quality is evident in its comprehensive quality control system. From the entry of raw materials, through the manufacturing of all components, to the assembly and final inspection of finished products, every step follows strict procedures and standards. NIDE has obtained ISO 9001 certification, and many of its products have received UL and CE approvals, demonstrating compliance with international safety and performance standards. To further enhance its service capacity, NIDE founded KN International, an affiliated organization centered on Ningbo Haishu KN International. This entity integrates various factories and resources related to motor components and motor automation machinery in China, forming a complete supply chain. By doing so, NIDE aims to free customers from the complexities of sourcing and managing multiple suppliers. Instead, the company provides a one-stop service that simplifies the entire procurement process. Customers can rely on NIDE to deliver everything they need for motor production, from individual components and specialized machinery to full production line integration and turnkey solutions. NIDE's approach to business is not limited to selling machines or parts. The company views itself as a strategic partner that supports its clients' long-term success. Its professional engineering and project teams work closely with customers to analyze manufacturing requirements, design customized production systems, and provide technical training and on-site support. This cooperative model allows NIDE to deliver optimized solutions that improve production efficiency, reduce downtime, and enhance product quality. Another distinguishing feature of NIDE Corporation is its innovation-driven culture. The company continuously explores new technologies and automation concepts to adapt to the rapidly changing landscape of the electric motor industry. Whether developing next-generation coil winding machines, advanced testing equipment, or fully automated assembly lines, NIDE ensures that each innovation aligns with global sustainability and energy efficiency goals. As the largest and most professional motor manufacturing machine exporter from China, NIDE has earned an outstanding reputation in the international market. Its products and services are highly valued by clients across various industries, including automotive, household appliances, industrial equipment, and renewable energy. Looking toward the future, NIDE remains committed to advancing automation technology and providing smarter, greener, and more efficient motor manufacturing solutions. With its global service network, cutting-edge engineering capabilities, and dedication to customer satisfaction, NIDE continues to lead the industry as a trusted partner in the development of modern motor technology. In summary, NIDE Corporation represents a perfect combination of innovation, quality, and reliability. Through its integrated global network, advanced R&D, and comprehensive service system, the company provides customers with a full package solution for motor manufacturing, covering everything from machinery and components to technical consultation and turnkey projects. Electric motors are one of the most essential inventions of modern industry. They convert electrical energy into mechanical motion and are found in almost every machine, from fans, pumps, and compressors to electric vehicles and industrial robots. In China, electric motor manufacturing has become an advanced and highly automated process. The country is now one of the world's largest producers of electric motors, supplying global markets with millions of units every year. The process of manufacturing an electric motor involves several key stages, including the production of the stator and rotor, coil winding, assembly, and quality testing. Each stage requires a combination of precision engineering, skilled labor, and advanced technology to ensure that the finished product performs efficiently and reliably. China's motor manufacturing industry is characterized by large-scale production facilities equipped with modern automation systems and high-precision machines. Many Chinese manufacturers specialize in producing a wide variety of motors, including induction motors, brushless DC motors, stepper motors, and servo motors. These are used across numerous sectors such as automotive, home appliances, manufacturing machinery, renewable energy systems, and robotics. The process begins with the creation of two primary components, the stator and the rotor, which together form the electromagnetic heart of the motor. The stator is the stationary part that generates a rotating magnetic field, while the rotor is the rotating component that produces motion. Once both are manufactured, they are carefully assembled and undergo rigorous quality checks to ensure they meet international performance standards. The stator serves as the foundation of the motor and is typically constructed from laminated sheets of silicon steel to minimize energy losses due to eddy currents. These laminations are stacked and pressed together to form the stator core, which contains evenly spaced slots where copper windings will later be placed. In modern Chinese factories, automated stator production lines handle most of the operations with minimal manual intervention. Robots or specialized feeding systems insert insulation paper into the slots of the stator core. This paper prevents electrical contact between the copper wire and the steel core, ensuring safe and efficient operation. After the insulation is in place, coil winding begins. Copper wire, chosen for its excellent conductivity, is wound around the core to form the stator coils. The winding pattern is carefully designed according to the motor's specifications, such as the number of poles, voltage rating, and intended application. Precision winding machines rotate the stator while feeding the copper wire into each slot with consistent tension and alignment. This automated process ensures uniformity, which is critical for balanced magnetic fields and efficient operation. Once winding is complete, the coils are tied and secured using lacing thread or other binding materials to prevent movement during operation. The wound stator then undergoes varnishing, where an insulating varnish is applied to the windings. This varnish penetrates the coils, bonding the wires together, improving insulation resistance, and protecting the windings from moisture, vibration, and mechanical wear. The varnish is usually applied by dipping or vacuum impregnation, followed by baking in an oven to cure it. The result is a robust, well-insulated stator capable of withstanding high temperatures and mechanical stresses during motor operation. The rotor is the rotating part of the motor that interacts with the stator's magnetic field to produce motion. There are several types of rotors depending on the motor design, but in most industrial and household electric motors, the squirrel cage rotor is the most common type. It consists of a laminated iron core with conductive bars usually made of aluminum or copper embedded along its length. The bars are connected at both ends by short-circuiting rings, forming a cage-like structure. In Chinese factories, rotor cores are stamped from silicon steel sheets using high-speed punching machines and stacked with great precision to ensure uniform magnetic properties. The assembly is then mounted on a shaft, which will later be supported by bearings inside the motor housing. For rotors made of aluminum, die casting is used to form the bars and end rings in one piece, providing excellent mechanical strength and conductivity. Once the rotor is assembled, it must be balanced to minimize vibration during operation. Even small imbalances can cause noise, wear, and energy loss. Balancing is typically done on computerized balancing machines that detect minute differences in weight distribution. Material is then added or removed as needed, often by drilling small holes or adding counterweights until the rotor runs smoothly. This precise balancing ensures that the motor will operate quietly, efficiently, and with minimal mechanical stress. After both the stator and rotor are complete, the next stage is motor assembly. In this stage, the stator is fixed into a housing made of cast iron, aluminum, or other durable materials. The rotor, mounted on its shaft, is inserted carefully into the stator's central opening, ensuring that the air gap between the two components is uniform all around. This gap plays a critical role in determining the motor's efficiency and torque characteristics, so precision alignment is essential. The assembly line in Chinese factories is typically semi-automated. Workers and robotic systems collaborate to install bearings, end covers, and cooling fans. Bearings support the rotor shaft and allow it to spin freely with minimal friction, while fans help dissipate the heat generated during operation. Electrical terminals and connection leads are also installed during the stage, enabling the motor to be connected to external power supplies. After mechanical assembly, the motor undergoes electrical connections and impregnation sealing if required. In some designs, additional insulation materials are inserted, and sensors or encoders may be fitted to monitor the motor's speed or temperature. The assembled unit is then labeled with identification data, such as model number, power rating, and serial code. Once assembly is complete, the finished motor is subjected to a series of tests and inspections to verify its performance and safety. Testing is one of the most critical steps in motor manufacturing, ensuring that each product meets both domestic and international quality standards. After passing all tests, the motors are cleaned, painted, and packaged for delivery. Each motor is labeled with its technical specifications and quality certification. Packaging is designed to protect the product from moisture, dust, and mechanical shock during transportation. Many Chinese manufacturers export their products worldwide. so packaging and labeling comply with international shipping standards. In recent years, Chinese electric motor manufacturers have made significant progress in environmental protection and energy efficiency. Production lines are increasingly adopting green manufacturing practices, such as recycling copper scrap, reusing process water, and reducing emissions from varnish curing ovens. High-efficiency motors are now a major focus, designed to consume less electricity while delivering the same or greater power output. Furthermore, technological innovation is transforming the industry. Many factories now use intelligent production systems that integrate robotics, machine vision, and data analytics. These technologies allow real-time monitoring of production parameters, predictive maintenance, and automatic adjustment of winding tension or varnish application. The result is higher consistency, reduced waste, and improved energy efficiency throughout the entire production chain. The production of electric motors in China combines precision engineering, automation, and strict quality control. From the careful winding of copper coils and impregnation of stators to the balancing of rotors and final testing, every stage of the process is optimized for reliability and performance. Chinese manufacturers have developed the capability to produce motors of all sizes and specifications, supporting industries around the world. The Chrysler Pentastar V6 engine production line in the United States represents one of the most advanced and efficient automotive engine manufacturing systems in the world. Designed to deliver high performance, durability, and fuel efficiency, the Pentastar V6 is a cornerstone of Chrysler's engine family. The production process combines automation, precision machining, and rigorous quality control to ensure every unit meets strict engineering standards. The manufacturing journey begins with the preparation of the main engine components, the cylinder block, cylinder heads, crankshaft, connecting rods, and pistons. The aluminum engine block, which forms the foundation of the V6 engine, is first cast using a high-pressure die casting process. This technique ensures a lightweight, yet strong structure capable of withstanding high combustion pressures. Once the blocks are cast, they are transferred to the machining area where robotic arms and CNC machines perform a series of precise operations. The block undergoes boring, honing, and drilling processes to create perfectly aligned cylinders, oil passages, and bolt holes. Next, the cylinder heads are produced. These are also made from aluminum to reduce overall engine weight. Automated CNC milling machines shape the combustion chambers, valve seats, and ports with micrometric precision. Robots handle the assembly of valve guides and seats, while laser sensors verify dimensional accuracy. The heads then move through a thorough cleaning and inspection stage to remove any residual debris from machining. Meanwhile, the crankshaft and connecting rods are forged from high-strength steel. The crankshaft undergoes grinding and polishing to ensure smooth rotation and proper balance. The connecting rods are machined, assembled with pistons, and fitted with piston rings. These sub-assemblies are then stored temporarily before the main engine assembly begins. During engine assembly, robotic systems and skilled technicians work together to integrate the machined components. The crankshaft is carefully placed into the block, followed by the installation of pistons and connecting rods. The cylinder heads are then bolted to the block using automated torque systems to guarantee uniform clamping force. Camshafts, timing chains, and valve mechanisms are added, forming the heart of the engine's valve train system. Electronic systems are also installed, including sensors, ignition coils, and the engine control unit. These components ensure optimal combustion, emissions control, and performance monitoring. The assembly line is highly automated, with synchronized robotic stations that handle most of the heavy and repetitive tasks, minimizing human error while increasing efficiency. After assembly, each engine undergoes rigorous testing. On the test benches, the engines are filled with oil and coolant, then started to check for leaks, vibrations, and abnormal noises. Performance parameters such as power output, fuel consumption, and emissions are recorded. Only engines that meet Chrysler's exacting quality standards proceed to packaging and shipping. The entire process emphasizes sustainability and energy efficiency. Recycled aluminum is used wherever possible, and machining fluids are filtered and reused. Modern facilities also employ advanced air filtration and noise reduction systems to maintain a safe and environmentally responsible workplace. In conclusion, the Chrysler Pentastar V6 engine production line in the United States showcases a perfect combination of precision engineering, automation, and human expertise. From casting to final testing, every step is carefully designed to produce reliable and high-performance engines that power millions of vehicles worldwide, reflecting the innovation and technological leadership of Chrysler's manufacturing excellence.